In this section, we're going to talk about polygon formulas. The first one we're going to talk about is the number, I don't know if I want to say the number, but the sum of the interior angles. If you have a polygon, which is just a multi-sided figure, has one side, a second, a third, has four sides. 1, 2, 3, 4. How many, and 5, excuse me, 4 and 5. How many degrees will the interior angles add up to? That is, this angle plus that angle plus that angle plus this angle plus that angle. And nice way to do this is to partition the figure into triangles. And the way you partition it is not unique. That is, somebody in your class might partition it differently, but nonetheless, everyone's gonna get the same number of triangles in a 5-sided figure. You get 3 triangles. And in the first triangle, you have this angle plus that part of the angle plus that angle. You have those 3 angles. And in triangle number 2, you have this angle and this angle and that angle. And in triangle number 3, you have this angle and this angle and this angle. But if you notice, that's exactly what I said at the beginning. I said you would get this whole angle and this whole angle and this whole angle and this whole angle and this whole angle at A, B, C, D, and E. Well, in angle A, we got it in 3 pieces. The red piece from angle 1, the green piece from angle 2, and the black from triangle 2, and the black piece from triangle 3. I added up all the angles, and of course, it's going to be 3 times 180. Why, of course? Because 3 triangles, the angles add up to 540 degrees. This was 5 sides. You had 3 times 180. What if I had 4 sides? Which of course is, well, not necessarily a square, but nonetheless 4 sides. You have a 4-sided figure, 4-sided polygon. 1, 2, 3, 4 sides. Side 1, 2, 3, and 4. Well, you can partition it this way to get 2 triangles. Or you could partition it this way to get 2 triangles. But nonetheless, you get 2 triangles. And if you add up all these angles, it better add up to 2 times 180, which is 360. But more importantly, 2 times 180. Well, what if we had a 6-sided figure? What if we have a 6-sided figure? 1, 2, 3, 4, 5, 6. Again, the way you make the triangles is up to you. You can go this way, and you will get 4 triangles. Or, we'll leave the first partition, or you could have gone that way. Nonetheless, you get 4 triangles. And these 4 triangle uses this angle and this angle and this whole angle and this whole angle and that whole angle and that whole angle and nothing else. So when you have a six-sided figure, you have 4 triangles. So the angles inside will add up to 4 times 180 degrees, which I guess is 720. Now, if you notice the pattern, let's look pretty much at this. I notice one thing that keeps coming up. 180, 180, 180. So, when we generalize and we talk about Nsides, I know one thing. If this pattern works, I'm going to have 180. And then I look, I'm like, well, 2 and 3 and 4, they keep going up by 1. Just like 4, 5, and 6 go up 1. Then I say, look at this. 4 minus 2 is 2. 5 minus 2, namely 3, is that number. 6 minus 2 is that number. If you take away 2 from the number of sides, you keep getting the number that you multiply the 180 by. N minus 2. Now, does this make sense? If you have a multi-sided figure, and I'm not even going to tell you how many sides I have out there, but what I am going to tell you is I'm going to put in another side. So right now, however many sides we have, we can get a certain number of triangles. Now, these 3 dots, it might mean just one side extra. It might mean 2 more sides. It might mean 22 more sides. I'm not saying how many more sides. So we're doing this in general. If I add in 1 more side, that is, instead of just having 1 side where I just erased, I add in 2 sides. Well, I get 1 more triangle. I get 1 more triangle. When I just had 1 side going from here to here, maybe I'm partitioned like this. However, I'm partitioned. But if I remove this 1 side, that is, if I add an extra side, well, what happens is I get an extra triangle. Okay, you add 1 more side, you get another triangle. That is, if you have 7 sides, you are going to get 5 triangles. So it'll be 5 times 180. If you have 8 sides, you're going to get 6 triangles. If you have n sides, you will get n minus 2 triangles. Okay, that's one theorem. Let's state it formally. If you have an n-sided figure, the number of degrees on the interior will be n minus 2 times 180. Theorem. Rule. Fact. In a n-sided polygon, their interior angles add up to n minus 2. 2 less than the number of sides times 180 degrees. It always is that. Because every time you add another side, you're going to get another gonna get another triangle. You only have 3 sides, you only get 1 triangle. N is 3, take away 2, you get 1 triangle. And we all know that the 3-sided polygon is a triangle. Okay. Now, here's another theorem. If you have a polygon, a multi-sided figure, and we have 1, 2, 3, 4, 5. If you extend one end of each line, say line 1, I extend it here. Line 2, I extend it here. Line 3, line 4, line 5. Okay, these angles, angle A, angle B, angle C, angle D, angle E. Not going to believe it. They add up to 180 degrees. Sorry, they add up to 360 degrees. They always add up to 360. And why is that? Well, in this 5-sided figure, 5 minus 2 is 3, I can make 3 triangles. Triangle 1, triangle 2, triangle 3. Well, if I call this angle U, this whole angle U, this whole angle V, this whole angle W, this whole angle X, and this whole angle Y. Basically, I don't need the partition. Now, I know a couple of things. I know that A plus U is 180. B plus V is 180. So, B plus V is 180. Well, okay, B plus V. C plus W. Make sure you see where I'm at. C plus W. I'm going clockwise. X plus D, or D plus X, is 180. E plus Y. E plus Y is 180. A plus U, let me write that first. A plus U is 180. Well, when I add up the right side, 1, 2, 3, 4, 5, I get 5 times 180. Well, when I add up the left sides, I get A plus B plus C plus D plus E. But then I get to add up those angles. But those were the angles inside. The angles inside, since it is a 5-sided figure, the angles inside will be 5 minus 2 times 180. It will be 3 times 180. Okay, so plus 3 times 180. So let's write this down a bit more nicely. Let me have a little bit more space. So here's angle side 5. So angle A plus B plus C plus D plus E plus 3 times 180. Well, take away the 3 times 180. Think of 180 as x. If you have 5 x's here and you take away 3 x's, well, you are left with 2 x's. If it works for x's, it must work for numbers. And that's where I get the results I want. Because on the left side, all that survived is angle A through E. A plus B plus C plus D plus E is 2 times 180 or 360. So it did work out. And amazingly, it always works out. Okay. The only thing is the way that I stated it, what did we just do? A 5-sided? Let's do a 6-sided figure. The way I stated it wasn't exactly right. So, we'll state it correctly now. Let's suppose you have a 6-sided figure. 3, 4, 5, and 6. You have vertex 1A and vertex B and vertex C and vertex D and vertex E and vertex F. There's A. Let's look at vertex X. There are 2 lines or 2 rays going to A. You have FA and FB. Extend one of those lines. I could extend BA. I could have extended FA. When it comes to B, I could extend BA, or I could extend BC. Now, why does it not matter? Because this angle and that angle are equal anyway. They are opposite angles. They may have 2 lines that cross and they're at opposite angles. So at each vertex, you extend one line. That's probably the cleanest way of saying it. At each vertex, you extend one of the lines. At C, I can come down like this, or I could have gone up like that. It doesn't matter. You decide. I'll go up here, I'll come down here, at E I'll go this way, and at F I'll go that way. Okay. So, angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 plus angle 6, they will add up to 360 degrees. And the reason is 1 plus A. So I'm calling this angle A and that angle B and that angle C, etc. So angle 1 plus angle A is a straight angle. It's 180 degrees. And the same with 2 and B. Angle 2 plus angle B is 180. And angle 3 plus angle C is 180. And angle 4 plus angle D is 180. And angle 5 plus angle E is 180. And angle 6 plus angle F is also 180 degrees. And when you add these up on the right side, you get 1, 2, 3, 4, 5, 6. You get 6 times 180 degrees. But now, if you have a 6-sided figure, one side, a second side, third side, a fourth side, a fifth, yep, we have 6 sides. And when you add up those angles, if you have 6-sided polygon, that generates 4 triangles. Say A through F will add up to 4 times 180. And remember, we're adding the whole left side. So let's not forget to add on angle 1 plus angle 2 plus angle 3. Ran out of room, but all the way up to angle 6. Knew I should have gone from right to left. Angle 6, angle 5, angle 4, angle 3, angle 2, plus angle 1. Well, if you take away 4 times 180 on the left side, you're just left with angle 1 The sum of the angle 1 and angle 2, angle 3, all the way up to angle 6. Those exterior angles. Okay, and if you take away 4 times 180 on the right side, you'll be left with 2 180s, which happens to be 360. The sum of the exterior angles, if you extend each vertex, you extend one line at each vertex, the sum of those exterior angles will always add up to 360 degrees. Always. Okay, so let's write up this theorem. Theorem. A n-sided polygon. If at each vertex you extend one line, then, let me not say these, but rather the sum, then the sum of their exterior angles, will equal 180 degrees. 360 degrees. A circle. The same degrees as in a circle. 360 degrees. It's amazing that that happens. Okay. Now, another formula. Another theorem. How many diagonals can you draw in a n-sided figure? How many diagonals can you draw? In a n-sided polygon, you can draw n times n minus 3 over 2 diagonals. Spell diagonals right and we'll be done. Okay, n times n minus 3 over 2 diagonals. If n equals 3, so you have n times n minus 3, that's how I write n, as 3, over 2. You have 3 times 0 over 2, which is 0 over 2, which is 0. Oops, keep forgetting that a. Diagonals. And this makes sense. If you have a three-sided figure, you can't draw any diagonals. A diagonal is any line that goes from one vertex to the other that wasn't part of the diagram. If you have a four-sided figure, if n equals 4, so this is how I'm going to write n. I'm going to read this formula the same way, except I write n differently. Looks like a 4 now. N times n minus 3 over 2. This is 4 times 1. 4 minus 3 is 1 over 2. 4 times 1 is 4. Divided by 2 is 2. You will get 2 diagonals. And as I'm sure you probably know, when you have, say, a square or a rectangle, not that this is either, but you get 2 diagonals. The formula seems to be working. That doesn't mean it's correct. Just because it worked for 3 and 4, and I'm going to show that it works for 5, that doesn't mean it works, but it does. This is the right formula. N times n minus 3 over 2. 5 minus 3 is 2. And before I multiply the 5 by the 2, I'm going to cancel them out. So you get 5 times 1 or 5. And this is precisely right. 1, 2, 3, 4, 5. I can draw one diagonal. Well, let me go in some order. Okay, let me go clockwise. I can draw this one. I can draw this one. And that's all I can draw from this point. So let me go to this point. So that's 2 so far. From this point, I can draw this one, and I can draw that one. That's another 2. From this one, I already have this one. I can draw that one. And that's all I can draw from here. From this vertex, I can go to here, but I already have it. I can go to here, I already have it. And that's all I can do. I don't have any extras. The diagonals are 5. There are 5 lines. I'll draw them in red. Hopefully it'll come out. 1, 2, 3, 4, 5 diagonals. Exactly what the formula said it will be. Okay, so basically, when it comes to polygons, you have these 3 theorems. The one that says the number of diagonals, the ones that talk about from each vertex, you're going to extend just one line. Those exterior angles will always add up to 360. And the other one that says that the sum of the angles will always, in an n-sided polygon, will always be 2 less than the number of sides, n minus 2, times 180 degrees. These are theorems that you need to know. You just need to know them cold. Just like you know that 4 times 5 is 20, you need to know in a geometry class that the number of diagonals in an n-sided figure is n times n minus 3 all over 2. And the sum of the interior angles of an n-sided polygon is n minus 2 times 180. Okay, so let us work out a couple of problems. They'll all be somewhat basic, and we'll move on from there. Okay, suppose you have a 5-sided figure. 1, 2, 3, 4, 5-sided figure. 1, 2, 3, 4, 5. And 1. They tell you this angle is 30 and this angle is 70. Actually, 110 or 100. And this angle is 110 and maybe this is 90. What is that angle? And how you do this is you have to know what the sum of the angles are for the whole figure. For the whole figure. Well, since it's 5 sides, it's a 5-sided polygon, that means the sum of their angles will be 2 less than 5 is 3 times 180. It's going to add up to 540. Okay, and I add up the angles. 30, 100, the unknown, 90, and 110. When I add these up, I get 13, I get 330. Okay, so you take away 330, whether the picture looks like it or not, it's 210 degrees. That angle right there, is 210 degrees. Doesn't look like it, but okay. Nonetheless, it's 210 degrees. And how do I know that? Because I have to add up to 540. I can make 3 triangles. They have to add up to 540. When one says regular polygon or regular 7-sided figure, that means all the angles are equal. All the interior angles are equal. What are the measurements of a regular 6-sided figure, 6-sided polygon? Okay, now whether you draw it or not, you should know that the angles sum up to, take away 2, 6 minus 2 is 4, times 180 degrees. Okay, now even before we multiply that out, which I was about to do, here is the answer. Up to doing some multiplication and division. The thing is, maybe we don't have to multiply 4 by 180. For example, if there were only 4 angles, the 4s would cancel out. But we have 1, 2, 3, 4, 5, 6 angles. So all the angles, if all the angles make believe add up, if all these 6 angles added up to 600 degrees, for simplicity, and they all are the same measurement, you divide by 6 and you'll discover they're all 100 degrees. That's why I'm dividing by 6. And 6 goes right into 18 3 times. Add a 0. That's how many times 6 goes into 180. And 4 times 3 is 12 with another 0. Okay, so each angle is 120 degrees. 120, 120, 120, all over the place. Okay, so you could figure out the measurements of each angle in a regular polygon. In fact, I can give you a formula. How many degrees in each angle of a regular n-sided polygon? And here's yet another formula. But this one I'm hoping is natural. N minus 2 times 180. That's the sum of all the n angles. By the way, if you have 3 sides, you have 3 angles. If you have a 4-sided, or that doesn't look like one, if you have a 4-sided figure, you have 4 angles. and so on. 2, 3, 4, 5. 1, 2, 3, 4, 5. You have 5 angles. So if you have an n-sided polygon, what I've written down so far is the sum of the angles. And you divide this by n, the number of angles. Oops, that didn't come out. You divide it by n, the number of angles, and that's the answer. That's the answer. Answer. Pretty neat. So you can now find out the exact measurements of any regular n-sided polygon. Suppose you have something like this. You have a 4-sided figure, 1, 2, 3, 4, with this side extended. You call it E, F, G, H, and J. And you're told that the measure of angle F is 110 degrees. The measure of angle G is 80 degrees. And H is 74. The measure of angle H is 74 degrees. And they want you to find the measure of angle E. Well, actually, let's change it. What's the measure of that angle? Well, when they say F, they mean that angle. Otherwise, you couldn't do it. I mean, if they meant that angle, how would you tell? Okay, when they talk about angle G being 80, they mean this one. This one's 110. H is 74. Okay, now, there's no reason to say, oh, this is piece of cake, angle 1 is 74, because of parallel lines. Nobody ever said HG and EF were parallel. Okay. Now, if you knew this angle, say this angle was 10 degrees for argument's sake, you can figure out that's 170, because they need to add up to 180. Whatever angle E is, angle 1 plus angle E will be 110. And you can figure out what to add to angle E to get to 180. I think I said they add up to 110. I meant 180. I had 110 on my mind. Well, these 3 angles that are given, they add up to, looks like 264. 264. Well, we have a 4-sided figure. I mean, real quickly, without even using the formula, I see 2 triangles. One up here, one down there. 180 and 180 is 360. I want to get 360. Well, 4 plus 6 gives me 0, carry the 1. That's 7. To get 6 or 16, I have to add 9. That gives me 16. And that adds up to 3. To get 3, I don't need anything here. That is, I now know the measure of angle E. Well, I know angle E plus angle 1 should add up to 180. 6 plus 4 gives me, my 0 gives me 10, carry the 1. This is 10 plus 8 more gives me the 8. Actually gives me 18. Carry the 1, well, that's the one I brought down. That must be the measure of angle 1. That's what you add to 96 to get to 180. The other thing is, learn to add things in parts. What do you add to 96 to get to 180? Well, I'm terrible at this addition subtraction. So I do it in steps. 96 plus 4 is 100. That's pretty easy. And what do you do to 100 to get to 180? Add 80 more. The answer is 84. Stop using your calculators. Start thinking a bit. So the measure of angle 1 is 84 degrees. I use the fact that the interior angle of a polygon, a four-sided polygon, was 180 times 2, 360. Now, suppose you have this figure. 1, 2, 3, 4, and 5. A five-sided figure. So, 2 less than 5 is 3 times 180. This adds up to 540. So you have 100, 1, 2, 3, 4, 5. 100, 110, 110, 120, and 100. Those add up to 540. Okay. But the question is, how many diagonals? How many diagonals can you draw? Well, of course, you can just go and draw it. Go to this point, and I'll go clockwise. That is, I'll go to here, and then there, and I already go there. And then we go to this angle. I can go to this one and to that one. Those are diagonals. That's all. For this one, I can go here, but that's already there. And I can go there. Okay, that's all I can do at that angle. At this angle, I can go here, but at that vertex, I can go here, but that's already there. And I can draw that diagonal. That's already drawn. Well, how many diagonals did I draw? The answer is 1, 2, 3, 4, and 5. There's one way of doing it, actually doing it. Or you can use the formula. Remember, in this case, n is 5. And the formula is n times n minus 3 over 2. And n is 5, so it's 5 times 5 minus 3, it's n times n minus 3 over 2. Well, 5 minus 3 is 2. And when you divide by 2, the 2's cancel, so you just get 5. But that's exactly how many I drew. I'd rather use the formula because if n is 25, if you have a 25-sided figure, first of all, try drawing a 25-sided figure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. You try to draw the diagonals in that. You want them more to be conventional, like 1, 2, 3, 4, 5, 6. Well, these angles are going to be so small, like it is here, or so big, they're almost going to look like straight lines. You're not even going to realize that that's the vertex. But you want to draw the 25-sided figure, go for it. Good luck in finding the number of diagonals. Good luck in finding in drawing the diagonals. And just for the fun of it, let's see how many it'll be. It's n times n minus 3 over 2, which is 25 times 22 over 2. 2 goes into 22 11 times. It is going to be 25 times 11. which is 275. So you want to draw 275 diagonals and keep good bookkeeping that you actually drew all 275. If in fact you did, go for it. If n is small, fair enough, maybe you can do it. For me, I'd rather use the formula. You subtract 3 from the number of edges, multiply it by the number of edges, and then divide that by 2. That sounds a lot easier to me. Now, let's reverse it. How many sides does a polygon have if the angles add up to 1800? The angles add up to 1800. Okay. Well, you know that n, the number of sides, minus 2 times 180 equals the sum of the angles, which we're told is 1800. Well, let's figure out what n minus 2 first is. Let's divide by 180 on both sides. So n minus 2 is equal to 180 divided by 18 is 10. Now, I know most of your teachers, and if you're a teacher yourself, most of you teach, you add 2 to both sides. Get your students to think, and students think. What number take away 2 is 10? The answer is 12. What if instead of 1800, I have 1080? 1080. Okay, so n minus 2 times 180 is 1080. Divide the left side by 180. You get 2 less than the number you want. Divide the other side by 180. First thing I would do is cancel out the zeros. What do you multiply 18 by to get to 108? Well, 18 times 6 is 48. 108. 6. 8 minus 2 is 6. So it is a 8-sided polygon if the angles add up to 1080. And what if it were a regular polygon? What if it were a regular polygon? How big is each angle? Well, they add up to 1080, and you have 8 of them. Well, we just said that 8 goes into 108 6 times evenly, and 8 goes into 0 times evenly. They're each going to be 60 degrees. Okay, this completes the section on polygons.